Next we're going to look at the hyperbola. If you go back to your ellipse equation, you'll notice the only difference between the hyperbola equation and the ellipse equation is that the hyperbola has a subtraction sign and the ellipse has an addition sign. So the ellipse equation that we looked at on the other page looked like this: x squared over 16 plus y squared over 9 equals 1, and this has a minus sign. So that's the difference between the ellipse and the hyperbola. Now it's interesting, if we were to take the ellipse that we drew before, this tells me this is an ellipse centered at the origin with a stretch of 4 in the x direction and 3 in the y direction. So if I draw this centered from the origin and go out 4 in the x direction and out 3 in the y direction, and draw these and kind of sketch in this ellipse here, like so, we can see that the ellipse fits right in the middle of the hyperbola. Now, if I go a step further and I draw a rectangle in which this ellipse is inscribed, so its vertices are touching the sides of the rectangle like so. So this is my distance 3 here, and this is my distance 4. So if I make a rectangle that stretches out 3 in the x or 4 in the x direction and 3 in the y direction, this is actually the box that is going to form the framework for drawing this hyperbola. Because if I draw in the diagonals of this box, it turns out that the diagonals of the box that encloses this ellipse are the asymptotes of the hyperbola. And remember, we talked about asymptotes are what the graph looks like if you zoom out and look at it from far off. In the long run, what does the graph look like? So we're going to go to a Desmos page that shows this even more clearly. So here is the graph, the hyperbola graph. If I put the ellipse in there, there's what the ellipse looks fitting inside. I'm going to put in the box and the asymptotes. Okay, so here's the box and the asymptotes. And then I am going to zoom out on this graph. So if I zoom out, notice how the graph gets more and more like just two crossed lines. In the middle, there's that box and that little curved part, but from a distance, basically it's just two crossed lines. So a hyperbola actually has a little curve in the middle, but the rest of it is very straight, unlike a parabola. A parabola continues to curve, but a hyperbola straightens out and goes along these asymptotes. Now, what's the difference between the x squared minus the y squared and the y squared minus the x squared? Notice that the x squared still have 16 under them and the y squared still have 9 under them. So the box is still the same size. We're still going out 4 in the x direction and 3 in the y direction. But the difference is, instead of opening left and right, this one opens up and down. Other than that, everything else is exactly the same. So notice this one, same box and asymptotes. It's still going to go plus or minus 3 in the y direction. It's still going to go plus or minus 4 in the x direction. So we're still going to see the same size box that we had before. A little sloppy there. And if we draw in the asymptotes are still, the diagonals of the box are still the asymptotes. Boy, this is sloppy compared to the way I normally draw these. Still the asymptotes for the other version of the hyperbola going the other direction. It's a little better. Okay, so with an x squared minus a y squared, it opens in the x direction. So it opens in the x direction. If we have a y squared minus an x squared for our hyperbola, it's going to open in the y direction. It's going to open up and down in the y direction. So that's how you tell the difference between which way it opens. The box and the asymptotes are still the same size for both of these. Now let's look at what would it look like if we now have one that is no longer at the origin? So see if you can draw the graph for this. You might try this yourself, but it is a little challenging, so I'm going to go ahead and help you with it. If you want to pause and try it yourself first, you can. The first thing we're going to do is locate the center. Now I want you to be really careful because it's a y squared minus an x squared, so we have to look here for the x coordinate and over here for the y coordinate. So the x coordinate is going to be 2 and the y coordinate -1. So 2, -1 is the center, so I'm going to plot that point. Then it tells me I'm going to go, if you look at the number under the x, it's 9. So I'm going to go plus or minus 3 in the x direction. There's a 4 underneath the y, so I'm going to go plus or minus 2 in the y direction to make the box. So if I counter 1, 2, 3 in the x direction both ways, and then 1, 2, and down 2. So my box is going to look like this. So there's the box. Now I'm going to draw in the asymptotes. Sometimes I draw dotted lines. I go ahead and draw solid here. Okay. Usually I probably should draw dotted because they are asymptotes. They're actually not part of the graph, but this will do for right now. So those are the asymptotes. So I'm going to go ahead and label these as asymptotes. So these are the asymptotes. Now, which direction does the graph open? Well, since it's a y squared first, it's going to open in the y direction. So the actual graph has its vertex right on the middle of the sides of the box, and then it curves and runs straight along the asymptotes like this. Curves and runs straight along the asymptotes like that. Now, be careful when you draw this. Do not draw it like this. Some students will just kind of draw it like this and totally ignore the asymptotes. That's not good. Oops, that's not what I want to do. I want to undo that. So we don't want to do that. The other thing you don't want to do is you're going along the asymptotes and then you curve it up like that. It doesn't do that either. So make sure you keep it nice and straight. A little more challenging is to take a graph and now write the equation for it. So let's see what we know from this. We see that the center is right here. So we have a center is 0, 5. So let's think, well, it's opening in the x direction. So we know we're going to have our x squared term first and then subtract our y squared term from that. Equal to 1, and we get some numbers under here. So I know that the center is the point 0, 5. So that means this would be x minus 0 and y minus 5. I could also just leave this as x squared, obviously. We see that the distance in the x direction is 5. So that makes this 25. The difficulty is how do you find the distance in the y direction? So what I'm going to do, and I'm using a ruler that you can't see here, but I am going to put a ruler so that it's slightly underneath this side and slightly over this, so it's going to be where the asymptote would be. And I'm going to draw in what I would approximate the asymptote to be. So that looks pretty close to what the asymptote would be. Actually, that's pretty decent. And I could do one the other direction, but one's enough because I know that the asymptote goes through the corner of the box. And I know one side of the box is here, so this has to be the corner of the box, which means that the box has a height of 2. So that makes this number 4. Okay. Another possible way to find the equation would be to find a point on the graph or approximate a point. This looks like the point 7, 7 approximately. So another thing I could do is write the equation and say x minus, basically substitute 7 for x. So we'll substitute this for x and y. So I'm going to say 7 minus 0 squared over 25 minus 7 minus 5 squared over, this is my unknown number, so I'll just call this, I'll call this c or something. Actually, I'll just call it r for radius. I can call it whatever I want to, equals 1. And I'll call that r squared because that's going to be my radius squared. Okay, so that would be 49 over 25 minus 4 over r squared equals 1. Now, you can solve this different ways. My preference is to clear fractions. So if I multiply both sides by both denominators, 25r squared, and I'm multiplying it by 25r squared over 1. So when I distribute the first, distribute 25r squared times 49 over 25, 25 divided by 25 is just 1. So I end up with 49r squared. Then when I multiply 25r squared times 4 over r squared divided by r squared is 1. So I just have 25 times 4 minus 100 equals 25r squared. I can subtract 49r squared from both sides, and I get negative 100 is equal to negative 24r squared, or negative 100 over negative 24 equals r squared. Well, this is approximately 4, which is what I got before. It's not exactly 4, but it's pretty close. It would probably be like 4.1 or something. So that's another way. Notice both of these are sort of approximations, because I don't know for sure that I drew the asymptote exactly correctly. I don't know for sure that this is exactly 7, 7. So both of these are approximations, but this would get you, if you're trying to do this for your graphing project and make a hyperbola, estimating where the box and asymptotes are for the graph you want is going to be really helpful in getting a pretty good ballpark figure for your equation.